Hello everyone, welcome to my YouTube channel Data Partnership. So first of all, Happy New Year to everyone. So this is my first video of 2026. I am coming after a long time. Today video is based on again flood likelihood. I have posted two videos earlier on flood likelihood. So this is because we learn with time, right? So earlier I was created those flood likelihood map by using Google Earth Engine. So it was mainly the riverine related flood risk I was talking about. Right, my intention was that, right? But right now, today I will go deep. I will take deep dive, right? So that it will be more clear to my audience, and you can use those skill in your project, right? So my earlier what I have done is I'm quickly going through. I flood likelihood like these sources I have talked about, right? And what are and this from where we have to see the means what are the sources, right? This NDMA, NRSC, SDMA, CWC, or if you are in another country, they have also different departments, right? So we have talked about static risk, right? And then we have included rainfall forecast also. So a lot of factors or parameters we have discussed, right? Different types of flood. So uh, we also talked about model base. So this is not model base I'm talking about. So we have these are the indicators, conditions, and what should be the flood likelihood, right? And then I showed you how to create that by using Google Earth Engine, right? So what we have done is we have taken slope and distance to river, right? Terrain slope we have derived from the DEM. So to improve the flood likelihood, my second video was where we have included rainfall data also. So now and this was the my my earlier video. I will share my description of that so that you can have a look on that. So today it is flood likelihood maps are often misunderstood. Basically, we need some understanding on that. So let's interpret it clearly, right? So we have four levels. What flood likelihood actually means, how to read value 0 to 1 or colors, how to interpret flood risk zones, and how to explain limitations. It's very important. So what does flood likelihood means? Flood likelihood is not a flood depth or flood extent map. It only represents the relative probability or susceptibility of an area to flooding based on the physical and environmental factors, right? So, in my model, what I have flood likelihood is a composite index from how much distance from the river, what is the slope, rainfall intensity built up, means impervious or surface in the case of urban. So answer is where is flooding more likely to occur compared to other areas, not when, how deep, and how long, right? So this is the difference. So we have right now in this my video, it is I have taken another area as compared to earlier. It is mainly the urban focus. So if see this is my this same area, but I have just extended it. So this is mainly the urban related flooding. So what I have done is similar to my previous video. I have added DEM. So we have created slope from DEM, and then we have normalized this slope, right? Then we have taken the river from the hydrosets, right? This is the hydroset data. It's all open source. So we have created the distance from this. We have normalized it also. We have right. Then we have included rain also, right, from the IMERG data. It is similar to my previous video. So we have clipped it at the with my AOI. So then now what is the difference is my previous videos we have now we have included land cover map of that area. So that we are talking about urban flooding, so we have most important thing is built up. So how much built up is there? So urban, so we have unmasked take built up is 0, right? If it is urban 1, other is 0. So we have, based on that, in urban flood likelihood we have added built up, right? We have given this 0.35 and 35% you can say, and add rainfall, slope, distance. This is the similar to earlier one. Only thing is that this time we have included built up. So now we have then flood, flood zone. This is urban flooding flood likelihood. Now it's a zoning, right? So based on that, where zone is less than 20, pixel is less than 20, then 1, otherwise 2, 3, 4, right? Great. So this is the simply the visualization. If we run this, then it will come like this, right? So it is coming. While it is coming, so we okay, so we have, I will just remove this AOI. Okay, so better this is. So you can see this is my, this is flood likelihood, right? So you can see we have two kind of color here, orange and blue, right? Light blue. So you can see we, wherever is our, you can see, if we see the satellite image, wherever is our this orange color, this is mainly the urban urban flooding. Means this area have more flood likelihood of flooding because it's a urban area. So, and you can see here there is one river also. Even this river, there is here is one river. This one you can see here. This is river. So in that, near to that, we have less. We have less probability of flooding because we are talking in the terms of urban flooding. So that's why I wanted to explain you in that in my today's video. That is the main crunch. Otherwise you can just copy paste this code and run the things, right? So so if we have value from 0 to 1, if you click here, suppose I go here, if I click here, so it means click here, so what is coming, it will 0.007. It means it's a come in between 0 to 1. So it means the value, it has less probability of flood likelihood. So you can say if 0 to is a very low likelihood, 0.2, 2.4 low likelihood, then moderate, high, and 8 to 0.8 to 1 is very high likelihood. So wherever we have taken this flood likelihood, it is 0.02 means very low. If it is built up, if we click here and the built up area like here, so it means it should come more, right? So it means 0.35, right? So 0.35 is coming into the this range, means low likelihood. So we have low likelihood here, very low likelihood or low likelihood. There are other factors also, we cannot say based on these parameters, but this is the just to, in case of if you don't have anything and you are starting from somewhere, so that's why it is very useful, right? So a pixel with means, of course, whosoever had better numbers then have much higher flood susceptibility than the zero point 0.3 pixel value. So why does a built up, now question will arise in your mind, that why does a built up area show higher flood likelihood than a point near the river? Because urban flooding is not the same as a river flooding. So our model is currently urban flood focus, not the fluvial. So that's why it is coming. So that's why we have given weightage to built up area more. So that's why it is coming. So now I will explain you better. So why this happened to my model means, you can see we have given distance to river, we have given only 10% chance. Even in for built up we have given 30%, 35%. It all depends, you can put 40, 50 also. It's all depend on the situations or the locations. So near river point may still be safe locally. It's a locally, right? Being near a river does not automatically mean flooding. Why? Especially when, if river is embanked, the land is slightly elevated, the slope allowed quick drainage, no heavy rainfall at that time, the pixel is not built up, right? Maybe it is something else. So our riverside point probably had low built up value, acceptable slope, no extreme rainfall, right? Of course, this there are a lot of built up area in that area. I know about that area. but this is the process, right? So built-up area near dominate urban flooding in cities because road, concrete, building, parking lots, rainwater cannot infiltrate the ground. Water accumulate quickly. Drainage system not over system get overwhelmed, and we all can see in our cities, right? So even moderate rate can cause flooding. So that is why built-up area equal to high flood likelihood, right? So in this case we have low flood likelihood because our it's coming into this range 0.35 at all, right? So distance to river has low weight 0.1, right? We intentionally put it. This means river proximity influences the result, but it does not dominate, right? This is correct for urban pluvial flooding because somewhere it happens. Pluvial means river flooding because any dam is there in the upstream. If you open that, then water can reach to the cities. It happens sometimes. It's not the fishing activities, but the river due to rain induced flooding is common nowadays in cities because of there are a lot of factors behind that, right? So in real world scenario, we can see that Delhi, Gurgaon, Bengaluru, flooding often happen far from rivers, even right on road, under flyovers in colonies. So not because river overflow, but because drains are blocked, rainfall intensity high, surfaces are impervious. Right. So that's why it happens. So now we can see here that we have flood zones also. Right. So we have this flood zones. You can see so in flood zones, this is coming. So how green is very low flood risk, yellow is two is a low flood risk. There are some orange color moderate flood risk, right? So means this is the typical urban flood analysis, right? And why flood zone scattered and patchy? It's a scattered here and there, right? Because this is one of the most common doubt and it is correct behavior. Highly localized, we all know that urban flooding is highly localized, street level, drainage dependent, influenced by impervious surfaces, so flood prone pixel appears along roads, right? You can see here, these are the routes, right? You can see clearly here, roads, intersections, and dense colonies near no slope pocket where drainage covers. So, unlike river flooding, urban flooding does not form large continuous polygon. That is the thing. So, you can try this. So, this is just what I wanted to show you. So basically what based on that you can also in you can check this with your study area. So you can use this code, and based on this code you can improve this, and you can improve whatever you want, right? If you are a developer, then you can do in a better way. So this is what I wanted to show you, that by using remotely sensed data, you can do this kind of activities in your project, right? So of course there are other thing, hydrodynamic modeling, flood modeling. Nowadays 1D 2D models are there. So but that we need a other skills, right? So that is not always required, frankly speaking. So that's why you can buy remotely open source geospatial data can be very helpful for you. Thank you. Please subscribe my channel and share and comment. Thank you.